So a greeting to you all. This is Rich Wycliffe, a biology chemistry teacher, and this is my audiovisual product of the USEP training, Kasenyi cluster, Mubende district, about ecology, relationship between organisms and population controls between the predator and the prey. The illustration below is for adaptations of predators to their move. So checking on that's the jaguar moving towards its prey, and that's the caiman around 12 feet. But the jaguar is a potential predator in terrestrial life. You know, it's very aquatic and it has swiftness. You can check that swiftness. It holds specifically by the neck using its sharp canines, and it carries the prey all away from its potential habitat. You can check that the crocodile is very efficient in water, but so it is trying to take it away from its habitat. So we are also switching to adaptations of the prey to survive. So on the screen view, that is an example of an assimilation. We are going to look at an ecosystem that is terrestrial, whereby we have the abiotic, that is land, and we have the living organisms. We are giving a case study of a rabbit living in its ecosystem, but now we are going to look at how populations of predator prey control populations of the other, whereby when predators are in place, it controls the populations of the prey, and even abundances of the prey can influence the population of the predators. So we are going to start our simulation whereby without mates, the prey cannot increase in number, though there is abundance of food. So there is abundance of food, but there is absence of mates. So here we shall add the mate. So when we add the mate, there will be interaction, therefore increasing the population of the generation. So we are still at generation 0 because no mating has yet taken place. So when mating takes place, the generation switches to 2. So interbreeding takes place, generation to generation, because there is no limiting factor. There is abundance of food, there are presence of mates, and it's only there is no intraspecific competition between rabbits of the same of the same species. So at graphical interpretation, we shall elaborate that the population for the rabbits increases exponentially generation to generation, and when the population of the rabbits is not controlled, it will saturate the whole universe with rabbits until when the biosphere reaches what to call the full carrying capacity. So that's the first scenario. When it reaches generation 5, the population moves. So that's the full saturation. So we can also switch to another simulation whereby we must also control the population before reaching its full saturation by involving what we call the predators. So at this time we add mates at the 0 generation, so that we increase the population generation to generation, so that when the population is increasing, there is abundance of food and there is no intraspecific competition. These are potential prey, thereby in presence, generation to generation, in absence of the predators, the population of the rabbits increases exponentially without competition. So intraspecific competition takes place, but it's not big enough to control their population. So what do? Under this simulation, we bring in the wolves. So how will the wolves control the population of the rabbits? Wherever wolves come in, their population increases, whereas those of the prey, that's what reduces. So it is a feeding relationship whereby when the population of the rabbits increases, the population of the wolves also increases. But in turn, when the rabbits reduce, the population of the wolves also reduces eventually, because they have been feeding on the rabbits. So it's either way. When the rabbits are high, the wolves increase. But when the wolves in turn increase, they will feed on the rabbits and they will starve. So that is also another simulation. So by the 7th generation, you will find that one rabbit will be remaining for the remaining wolves. So the wolves will starve in absence of food. But there is another limiting factor that can control all. That is absence of food, and that's the last simulation. If we are to start over, the last simulation is what we call the overall factor that controls all the predator and the prey. That's food. So we are going to eliminate food. So by the zero generation, the population is increasing because there is abundance of food. So what do? We wait until when you reach the fourth generation, when the food is present for the rabbits and the rabbits population is high, so we shall involve the wolves because they have got food. So after that, we can put limited food that can control both the population of the predators and the wolves. So we are creating what we call scarcity of food this time round. So scarcity of food will affect both population of the predator and the prey as a limiting factor. So here, this is where the principle comes in, that when organisms occupy the same niche, they compete for the same resources until one of them becomes extinct.